Hey there! In this video, I'll share with you an effective method to perform calculations involving the mass of isotopes and their relative abundance. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Calculating isotopic mass will help us to set out the solution for our problem with much greater clarity. So let's begin by determining the isotopic mass of these two isotopes of chlorine, chlorine 35 and chlorine 37. This number here, 35, in the superscript left position gives us the mass number, and the number below that in the subscript left position gives us the atomic number. The atomic number is the number of protons in the nucleus of an atom, and the mass number gives us the number of protons plus the number of neutrons in the nucleus of an atom. Now, both of these atoms of chlorine have the same number of protons. They have the same atomic number, but they have different mass numbers, which tells us that they have different numbers of neutrons. And that is what isotopes are. Isotopes are atoms of the same element with the same number of protons or atomic number, but different number of neutrons, giving rise to different mass numbers. So the number of neutrons for chlorine 35 is 18, and that of chlorine 37 is 20. How do we get that? We simply subtract the atomic number from the mass number. Now, in a sample of chlorine, there will be 75% of the chlorine atoms having a mass of 35 and 25% of the chlorine atoms having a mass of 37. These percentages are known as the relative abundance of the isotopes. To calculate the isotopic mass, we simply multiply the mass of the isotope times the relative abundance, so that is 75 over 100, and this we need to add to the mass of the other isotope times its relative abundance, and that should give us the average isotopic mass. In this case, we will have 35, and we will write the percentage here in the form of decimal, so it will be 0.75 plus 37 times 0.25, and that must be equivalent to the average isotopic mass. When we multiply 35 times 0.75, we get 26.25, and when we multiply 37 times 0.25, we get 9.25, and when we add those two together, we get 35.5, which is the average isotopic mass of chlorine. So let's transfer our knowledge of how to determine the isotopic mass to our problem over here, where we have been given the isotopic mass, which is 14.007, but we have not been given the percentage relative abundance which we are asked to determine. Now, the sum of the product of the mass of this isotope and its relative abundance and the mass of this isotope and its relative abundance must be equivalent to 14.007, the average isotopic mass. So let's set out our solution in this format. So let's start by writing the mass of this isotope, 14.003, times, and let's use X to represent the abundance of this isotope, plus the mass of this isotope, 15.000, and remember that these two relative abundances are equivalent to 100%, and expressed as a decimal, these two numbers add up to 1. So if the relative abundance of this isotope is X and the relative abundance of this isotope is related to this isotope, in terms of percentage, they must add up to 100%. In terms of a decimal, they must add up to 1. Then we can express the relative abundance of this isotope as 1 minus X. And that must be equivalent to 14.007. Finally, let's solve the equation to find out what our values will be. This here is 14.003x, and we will use the distributive law to expand this bracket here. So that will be 15 minus 15.000x equals 14.007. Now, grouping like terms, we will have 14.003x minus 15 must be equivalent to 14 minus 15. Subtracting x's here will give us negative 0.997, and subtracting over here will give us negative 0.993. Dividing through by negative 0.997 on both sides will give us 0.996. Therefore, the percentage relative abundance of this isotope is 99.6%, and that of this isotope, of course, found by subtracting this amount from 100, gives us 0.004%. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to recall the definition for isotopes, explain the term relative abundance, and perform calculations of average isotopic mass and the relative abundance of isotopes. Good luck on your exams, and I'll see you next time.